This is a lesson on reaction mechanisms. Reaction mechanisms trying to make sense or coordinate or combine the idea of the balanced chemical reaction and the rate law. And it turns out that it's impossible from the balanced equation to come up with the rate law. And this section kind of explains what is going on and how that works. Say you have a reaction Xe plus F2 yields XeF2. This is a one-step reaction, and the rate is K, rate law constant, times Xe times F2. Another reaction could be NO2 plus CO yields NO plus CO2, but in this case, the rate law is found about to be NO2 squared, which the first one makes sense. You got an Xe and you got an F2, and that is the reaction that you have. Next equation, you have NO2 and CO, but not only you don't have the CO, you have two NOs, and there's only one thing. So what we try to do in chemistry is to come up with a reaction mechanism, which is a series of steps each with its own rate, and the slowest step is the rate determining step. Rate determining step, RDS. So for this reaction here, what might happen is you have NO2 plus NO2 makes NO3 plus NO, and this is the slowest step, and then quickly NO3 reacts with CO to form NO2 plus CO2, and this is a faster step. The slowest step is the rate determining step. If you add the two together, if you make something and then it's used up, that's called the intermediate or reaction intermediate. So in this case, NO3 is the reaction intermediate. These are not reaction intermediates because it's made and produced. So when you add up these, you get NO2 plus CO makes NO plus CO2, which is the original reaction that you're trying to strive for. And if you do the rate step from this, the slowest step, you get NO2 times NO2, which is the rate law. This reaction here could be if F2 makes F plus F, or 2F, And then that reacts with the Xc to make XeF, and then that reacts with another F, XeF2. If this is a slow step, then the reaction would be rate equals K times concentration F2. But that is not what the reaction is. The only way to get this is to have Xe plus F2. So this is a one-step reaction from that. How do you determine these rate determining steps in the reaction mechanism? It takes some intuition, chemical skills, and things like that. Nowadays, they can phase a laser quick enough so that what they look for, they can tune it to a XEF. And when they see that XEF, and then they time it, and then they look for things. But that's how they do it now. They have flashes of laser tuned to what you think might be one of the reaction intermediates, and when it shows up, it times it, and then that way they can get the order of things that show up. It is possible to have fractional exponents, and that is if you have a reaction, and this is not on the AP exam or anything like that, it's not even on my exam or a quiz, but it happens. If you have something like A plus B yields X plus Y, overall reaction, is A plus B plus C yields Y plus Z. If you have A plus B, X plus Y, and that's fast, and then C plus X yields Z, and that's the slow step. Well, the rate is K times concentration of C times concentration of X. But the rate law has to include the things that are in original equation. So since there's no X, you have to manipulate these equations to find out what X is in terms of A plus B and put it back in. In this case, using math from the next chapter that we don't know yet, you can find out that the rate law, K, concentration of C, concentration of A to the 1/2, times concentration of B to the 1/2. Again, it is possible to have fractional exponents for rate laws. You're not going to be responsible for that. We talked about things that are produced and then used up. Those are called reaction intermediates. And we're going to talk about that in the next section, intermediates. If you have something that's there originally but is reproduced in the end, this is a catalyst. A catalyst might be used in the equation, in the reaction, but then it is also produced if you cancel them out. So both reaction intermediate and the catalyst cancel out. The difference is you produce a reaction intermediate and then it is consumed. Catalyst, you start with a catalyst and then it is produced. that is it on reaction intermediate or reaction mechanisms.